Hello students. Now we see differentiation of function in modulus. Okay. So problem number 1. If f of x equal to under root of x square plus 6x plus 9, find f dash of x. Okay. Now x square plus 6x plus 9 is an under root. So we write this as x plus 3 whole square. Okay. So when you expand x plus 3 whole square, we get x square plus 6x plus 9. And we know under root of x square is defined as mod of x. Similarly, under root of x plus 3 whole square is x plus mod of x plus 3. Now take x plus 3 equals 0. And x is equal to minus 3. Okay. So draw a number line here, minus 3. For x greater than minus 3, this is positive. X plus 3 is positive. Less than minus 3, minus 4, minus 5, minus 6, etc. X plus 3 is negative. Okay. So minus. So we defined mod of x plus 3 as in two intervals. One is greater than minus 3 and less than minus 3. Okay. So we know mod of x. Mod of x is defined as if x is greater than or equal to 0, mod of x is x. Less than 0, mod of x is defined as minus x. Okay. Similarly, we write mod of x plus 3 as x less than minus 3. Okay. X plus 3 is negative. So mod of x plus 3 become minus of x plus 3. Okay. And x greater than minus 3. Greater than minus 3 means minus 2, minus 1, etc. Okay. This become x plus 3 is positive. So modulus of any positive value is plus x. Modulus of any negative value equal to minus x. Okay. So x plus 3. Now differentiating this f dash of x. Differentiation of x plus 3 is minus of 1 plus 0 for x less than minus 3. This is 1. X is greater than minus 3. Don't write equal because at x is equal to minus 3, the derivative does not exist. Okay. So minus 1 if less than minus 3 and plus 1 if x is greater than minus 3. Okay. At x is equal to minus 3, f dash of x does not exist. Because left hand derivative is minus 1. At x is equal to minus 3. Okay. Left hand derivative is minus 1. Right hand derivative is plus 1. They are not same. So left hand derivative is not equal to right hand derivative. Therefore at x is equal to minus 3, f dash of x does not exist. Okay. But less than minus 3, f dash of x is minus 1, and greater than minus 3, f dash of x is plus 1. Okay. Next problem. F of x is x square okay. Then find f dash of x. Now take x square equal 0. Factorize it. X minus 2 into x minus 1 equal 0. So x values are 1, 2. So now take the number line. So x value 1 here, x value 2, okay. So greater than 2, for x greater than 2 plus, we get plus value. In between 1 and 2, we get x square minus 3x plus 2 is negative. Less than 1, okay, that is 0.5. 0.5 minus 2 is minus 1.5 into minus 0.5, minus plus, again plus, okay. So for x greater than 2, less than 1, f of x is positive, and between 1 and 2, f of x is negative. That is x square minus 3x plus 2 is negative, okay. So we divide f of x as two intervals, okay. First one is x is less than or equal to 1 and x is greater than or equal to 2, okay. For x less than or equal to 1, x greater than or equal to 2, okay. For x less than or equal to 1, x greater than or equal to 2, x square minus 3x plus 2 is greater than or equal to 0, okay. So in between greater than 1 less than 2, x square minus 3x plus 2 is negative, less than 0, okay. So for x less than or equal to 1 and greater than or equal to x square minus 3x plus 2 is positive, therefore mod is written as plus x square minus 3x plus 2, okay. If x lies between 1 and 2, x square minus 3x plus 2 is negative, so we write mod of that x square minus 3x plus 2 is equal to minus of that value. So minus of x square minus 3x plus 2, okay. Now we have to differentiate. F dash of x, differentiation of x square is 2x, differentiation of 3x is 3. If x less than or equal to 1 and x less than not equal to 1, okay. For 1 and 2 we have to check derivative exists or not, okay. So x less than 1 and x is greater than 2, so 1 and 2 derivative does not exist, okay. And for if x is greater than 1, less than 2, differentiation of the function is minus of 2x minus 3, okay. This is the derivative of the functions. Now third question, differentiate log of mod of x, x is not equal to 0, okay. Take f of x equal to log of mod of x, x not equal to 0. And now there are two interval, one is x is greater than 0 and less than 0, okay. So first one is, first of all we know about log x, okay. For 0 to 1, if x is greater than 0, less than 1, log x is negative, okay. Greater than 1, if x is greater than 1, log 1 is 0, okay. Greater than or equal to 1, log x is greater than or equal to 0, okay. This is the log x value, but here mod of x, okay, log of mod of x. So we define the x value as negative value, positive value. Log x is not defined for negative value of x. Log x is not defined for negative value of x, okay, but log of mod of x is defined for both negative and positive value, okay. If x is greater than 0, If x is greater than 0, mod of x is plus x, okay? So it become log x, okay? If x is greater than 0, mod of x is what? Equal to x, okay? If x is less than 0, what is mod of x? Minus x, okay? So log of minus x, okay? So we know mod of x, okay? Mod of x, if x is greater than or equal to 0. If x is negative, mod of x become minus x, okay? Note this. Similarly, I am applying here. For x is greater than 0, mod of x is x, so I am writing x. Less than 0, mod of x is minus x here, so log of minus x, okay? Now if x is, for example, I am taking x is equal to minus 2, so log of minus 2, it becomes plus 2 log 2, okay? Now differentiating this, differentiation of log x is 1 by x. If x is greater than 0, differentiation of log of minus x, use log rule here, 1 by minus x, again differentiating minus x minus 1. If x is less than 0, okay, f dash of x is not defined at x is 0, okay, 1 by 0 is not defined. So 1 by x, if x is greater than 0, minus minus plus, so again 1 by x, if x is less than 0, okay, this is the value of f dash of x for log of mod of x. Therefore, f dash of x is 1 by x for all x. So for all x minus 0 except 0, okay? So next one, if f of x equal to mod of log x for x is not equal to 1. Okay, find f dash of x. Now I am taking two intervals. Log x is defined as defined in two intervals. One is 0 to 1 and greater than 1. Okay, I am taking the two intervals. X is greater than 0, less than 1. Log x is negative. Okay, f of x equal to mod of log x. For 0 to 1, usually for 0 to 1, log x has negative value. So mod of log x, so log x is negative value means mod of log x means minus log x. Okay. For log x is less than 0, if x is greater than 0, less than 1. If log x is negative in the interval 0 to 1, definitely mod of log x become minus log x and greater than 1. Okay. And find out the interval such that the modulus is negative and positive. For 0 to 1, log of the function is modulus of log x. Okay, and identify the interval such that log x is negative and positive. For 0 to 1, log x is negative, so I am writing minus log x. For greater than 1, log x is positive, so I am writing mod of log x is plus log x. Okay, so find out the interval such that the modulus of the function is negative and positive. Okay, if function is under a modulus. Now differentiating, so f dash of x, differentiation of log x is 1 by x, so minus 1 by x. For x greater than 0, less than 1, differentiation of log x is plus 1 by x for x is greater than 1. Okay, that's all. This is the derivatives. So next problem. So if f of x equal to under root of 1 minus sin tx in the interval 0 to pi by 2, find f dash of x. First of all, we modify the functions. Okay, right, 1 is equal to sin square x plus cos square x. By trigonometry formula, sin 2x is 2 sin x cos x. Okay, this is in the form of a square plus b square minus 2ab. So I am writing as cos x minus sin x whole square. Okay, we know under root of x square is mod of x. Similarly, it is in modulus of cos x minus sin x, right now. Okay, this is f of x. Okay, now we have to find the derivative in the interval 0 to pi by 2. Okay, so in 0 to pi by 2, I am taking the two intervals 0 to 45 and 45 to 90, 0 to pi by 4 and pi by 4 to pi by 2. Okay, in 0 to pi by 4, cos x is greater than sin x. Okay, cos x is greater than sin x. Okay, cos x is greater than sin x if in the interval of 0 to pi by 4. At x is equal to pi by 4, both sin x and cos x intersect. Okay, intersect. And if greater than pi by 4, okay, if x is greater than pi by 4, if x is greater than pi by 4 less than pi by 2, okay, cos x is less than sin x is greater. Okay, if you see the curve in sin x cos x, you can easily identify that 0 to 45, 0 to pi by 4, cos curve is above the sin curve. Okay, and pi by 4 to pi by 2, cos curve is below the sin curve. Okay, so if in the interval 0 to 45, cos x is greater than sin x, so mod of cos x minus sin x is positive, so it becomes same plus cos x minus sin x. In pi by 4 to pi by 2, cos x is less than sin x, so sin x is greater, so this become cos x minus sin x become negative value, so mod of cos x minus sin x become minus of cos x minus sin x. Okay, so I am writing this as f of x equal to, if x is greater than 0 less than pi by 4, in 0 to pi by 4, cos x is greater than sin x, therefore this cos x minus sin x is positive, so modulus of positive value equal to same value. Okay, so we get cos x minus sin x. Okay, if interval is greater than pi by 4 less than pi by 2, cos x is less than sin x, that is sin x is greater value, so definitely this cos x minus sin x become negative. Okay, so this become minus of cos x minus sin x. Okay, now you have to differentiate this. F dash of x is equal to differentiation of cos x is minus sin x, differentiation of sin x is cos x. If x is greater than 0 less than 5 by 4, minus of differentiation of cos x is minus sin x, sin x is cos x, if the interval is pi by 4 to pi by 2. Okay, therefore, so we write f dash of x is equal to, take minus is common here, so sin x minus of sin x plus cos x, if x is greater than 0 less than pi by 4, multiply minus inside, we get sin x plus cos x, if x is greater than pi by 4 less than pi by 2. Okay, so next question, J in main 2020, if y of alpha equal to under root of 2 times tan alpha plus cot alpha divided by 1 plus tan square alpha plus 1 by sin square alpha. So alpha belongs to 3 pi by 4 2 pi, then dy by d alpha at alpha equal to 5 pi by 6 is A option 4, B option is -4, C option is 4 by 3, D option is -1 by 4. Okay. First of all, I am taking the function under root. Okay. So 2 times take and simplify. First of all, we simplify the function under root and then take the square root. Okay. So 2 times tan alpha plus cot alpha divided by 1 plus tan square alpha plus 1 by sin square alpha. Okay. So we know tan alpha plus cot alpha. Okay, 1 tan alpha plus cot alpha. This is equal sin by cos. Cot alpha is cos alpha by sin alpha. Take LCM, sin square alpha plus cos square alpha 1 divided by sin alpha cos alpha. Okay, this is the value of what? Tan alpha plus cot alpha. So I am writing tan alpha plus cot alpha as 1 divided by sin alpha cot alpha cos alpha, and 1 plus tan square alpha is secant square alpha plus 1 by sin square alpha. Okay, so 2 times sin alpha cos alpha into secant square alpha plus 1 by sin square alpha. Okay. Now 1 by cos alpha is 1 by secant alpha. 1 secant alpha cancel. Okay. So 1 by cos alpha is again 1 by secant alpha is cos alpha. So 2 cos alpha by sin alpha plus 1 by sin square alpha. Okay. Now take LCM. Sin square alpha is LCM. Okay. 2 sin alpha cos alpha plus 1. So write 1 as sin square alpha plus cos square alpha. Sin square alpha plus cos square alpha divided by sin square alpha. We write the numerator as sin alpha plus cos alpha whole square. Okay, using a plus b whole square formula by sin square alpha. Now this is the value of 2 times tan alpha plus cot alpha divided by 1 plus tan square alpha plus 1 by sin square alpha. Now I am taking the square root under root of 2 times equal to, so under root of, okay, by 1 plus tan square alpha equal to sin alpha plus cos alpha whole square divided by sine square alpha. So under root of sine alpha plus cos alpha whole square is modulus. Okay. So mod of sine alpha plus cos alpha. Similarly, under root of sine square alpha is mod of sine alpha. Okay. Here given in the given problem, alpha belongs to 3 pi by 4 to pi, that is 135 to 180. Okay. So definitely 3 by 4 to pi comes in the sine quadrant. Okay. In sine quadrant, sine is positive, cos is negative. Okay. So in so 3 by 4 to pi comes in the second quadrant. In second quadrant, sine alpha is positive, cos alpha is negative. Okay. In 3 by 4 to pi, cos alpha is greater than sine alpha in magnitude. So definitely sine alpha cos alpha plus cos alpha is less than 0. Okay. So in this interval, alpha belongs to 3 by 4 to pi, sine alpha plus cos alpha is less than 0 and sine alpha is greater than 0. Okay. So I am writing this as mod of sine alpha plus cos alpha is minus of, because we get the modulus. So sine alpha plus cos alpha negative, then mod of sine alpha plus cos alpha become minus sine alpha plus cos alpha. Okay, by mod of sine alpha is sine alpha, because sine alpha is positive. Okay, this is the function of f of alpha. Okay, so decompose. So sine alpha by sine alpha is 1, cos by sine alpha is cot alpha. Now differentiate. So f dash of alpha is differentiation of 1 is 0, differentiating cot alpha minus cosecant square alpha, minus minus plus cosecant square alpha. Okay, but question is find dy by dx at 5 pi by 6. Okay, so now we find f dash of 5 pi by 6, that is cosecant square 5 pi by 6. So cosecant square, this is pi minus pi by 6. Okay, so 180 minus theta, and 180 minus theta comes in second quadrant. Second quadrant is cosine is positive, so cosecant square pi by 6. Okay, that is 2 square, that is 4. Okay, the correct option is 4. Okay.